Watch out there. You're all right. And I'll apologize in advance. How molecules bend, wiggle, and vibrate composes about 3 slides. So, but I hope you guys will all enjoy the talk nevertheless. I want to focus today on something that would be relevant to all of us, and it's a problem I particularly struggled with as I went through community college and then went through my bachelor's program at Illinois State and even into my program at Stanford where I am today. And my issue is, for some reason, as we grow up, all of the, I don't know if you guys can see the red thing, all of the textbooks were given, the books were given, the manuscripts were told to read, and the research papers you find online, they're filled with a lot of jargon. And even when they go through pains to create good visual aids, they're not effective. For some reason, as a society, we think this is a good way to communicate information to one another. And, you know, when I started off and I started taking calculus and other classes like this, textbooks become increasingly more and more like this, and it's really hard to read, it's intimidating, and you don't get as much out of it as you really should. And even when you do come across a visual aid that looks promising, sometimes there's issues with it. I'm going to tell you a quick story I got from a friend who worked at Los Alamos last summer. And a group there published this paper talking about a networked quantum communication systems they developed. And the friend who worked there, she was talking to the guys, and soon after they published this article, Gizmodo and MIT Tech Review picked it up, and this is what they reported. Government lab reveals it has operated quantum internet for 2 years. It's, you know, it's not an accurate depiction of what the work was actually about. It's sensationalist, and frankly, it sounds a little scary. It's, what is this quantum internet thing, and why has the government been keeping it from me for 2 years? And you might be tempted to place all of the blame on the publisher. They're being sensationalist, they're putting words in the researcher's mouth. But, you know, if we look back on the image included in the paper, I can see where that idea of a quantum internet was reinforced. You have a bunch of devices, and they're all connected. This looks a lot, to me, like what I would call the internet. So there's kind of 2 problems with how we communicate to each other as we grow up. First off, we have these thick walls of text that are mentally taxing, and when we do include figures, they don't do a really good job of engaging the audience, which is kind of weird because there's plenty of counterexamples. Geologists, they're really fabulous at expressing themselves visually. For instance, here's an example I'm familiar with growing up that explains kind of the life cycle of rocks. First they start as magma, a volcano erupts, and over time they erode, go to the bottom of the ocean, and then over time the cycle repeats. Another example comes from my close friend Stuart Koppel. He produced this for the Science Teaching Through Art exhibition last year, and he actually showed this today. And so even physicists are capable of creating compelling visual aids. And what this is showing is in the first few seconds of creation after the Big Bang, the universe rapidly expanded, almost to the size it is today. So we're capable of creating good visual aids, but often we don't explain our ideas visually as we grow up. We become more and more inclined to actually use words. And you know, I kind of want to examine why, and I'm going to do an activity I learned from the D school at Stanford, the design school. They're all about kind of holistic learning, and it's kind of fun. And it's going to mirror a workshop we actually do in the Science Teaching Through Art workshops, where we kind of try and teach graduate students at Stanford how to effectively communicate their research. And what we ask them to do is take 5 minutes to prototype a poster depicting their research. And then we ask them to reflect on the activity, and usually it's a very daunting task. And so I want to do an activity with everyone to show why this is hard. So what we're going to do is actually sketch your partner. Everyone should have a piece of paper where they sat down today, and I want you all to partner up in pairs. And if you need a pen, just raise your hand and we'll hand one out. I'm going to give you 1 minute to sketch your partner.
Kind of want to like point this to the
a quick sketch here, nothing too impressive.
Oh, I don't want to show off.
I'm apologizing right now. Okay.
20 seconds left. Better finish quick. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, everyone stop. Everyone stop where you are. All right. Now what we're going to do, share it with your partner. You have to show your partner what you just drew. Alright, sounds like everyone had a little fun with that. So let's pull it back in now and quiet down. And let's really quick debrief. Would anyone like to share with me the experience of sharing their drawing with their partner? Exhilarating, okay. Anyone else want to share? There's no right or wrong answers.
I kind of went for the details first instead of the overall facial structure. So I went straight for the hair and I completely forgot about the eyes until the end and nose. So, yeah, I don't know what.
Yeah, that's interesting. Like sometimes we want to add all that detail up front, even though we know there's that time limit. And honestly, we have just invested, just get done rough in the first place, right? And the point I want to make here, and I heard a lot of people say this, a lot of people said sorry. Which is really interesting, because, you know, as children, we never apologized. We draw an image and we'd show it to our friends and family, and, you know, we'd be excited to show them, and our friends and family would be excited to see it. Hopefully you drew better than little Matt, but, you know, hopefully. And you know, even though the pictures were a little silly, you know, they did accurately portray what we wanted to talk about. I think everyone would agree here this is a picture about a child's family and home. And it's only as we get older that we shy away from these simple expressions of ideas and we favor more complicated forms of expression. And this progression also follows kind of the literature we're exposed to. As children, we have really awesome books, lots of pictures, and you don't even need the words there in the Hungry Hungry Caterpillar. I know what the caterpillar's all about. He wants to eat. And then as we move on, the books get less and less images and more text. And we kind of start to lose some of that creativity. And however, me when I was reading these, I really enjoyed parading around the house as Captain Underpants to, you know, my parents' great disgrace and shame. But by the time we're reading Harry Potter, about the only imagery in the book is on the cover, and the rest of it's entirely text. And, you know, there's starting to be more and more exceptions to this rule. People are recognizing the value of illustration. The Harry Potter books are being all reprinted with lots of nice illustrations, and, you know, graphic novels are an amazing form of visual communication. They effectively communicate their ideas, and they use very little words. However, the standard as we move through college, community college, into our bachelor's programs and onto graduate school if you go there, is the papers look like this. And even today, trying to read something like this, it causes a lot of anxiety and it's hard. So let me give you an example of how my creative expression has changed as I've moved on through school. I started off at Heartland Community College, and in one of my math classes, we were given the option to choose anything from our differential equations book and apply it somehow. And I decided, I wanted to use math to make something more artistic. I don't have the original picture, so I just sketched it out. But I used a parametric system of differential equations to make a vector plot that sketched out a smiley face that my teacher inevitably found a little creepy. She's just like, I'll take it, I'll give you the grade, Matt, but that's a little creepy. And by the time I got to my bachelor's program, about as creative as I got was in my classical physics class, where just kind of a tongue-in-cheek joke, I turned in all my homework assignments on Subway napkins to my professor. He'd continually complain that sometimes he'd lose them and use them to wipe his mouth while sipping coffee while grading homework. And by the time I did my first manuscript in undergraduate, it's just this wall of text. This is the paper I've been showing you all along. And it's a little shameful. This is what we see as effective communication. And especially on a paper that actually we use a lot of really great visualizations to develop. In fact, what the paper studied is theoretically, let's say, the creation and annihilation of particles and antiparticle pairs from the vacuum. So if I took this room and I sucked all the air out of it, and we had an instrument sensitive enough to the smallest timescales in the universe, we'd actually see matter come in and out of existence very quickly, and then very quickly annihilate one another. So it's this very nice visual process where you see in this video, particles are created and then slammed back into each other and destroy one another. And when we were talking about this idea with my mentors, Grobe and Charles Su, this is what we drew on the board when talking about the project. We didn't draw or write down any of these words I've shown you here. We drew pictures similar to this. So it's a little silly when we decide when it's time to be professional and communicate our ideas to other people in our field, we decide to use these walls of text that we would never use to communicate with people inside our lab. And I was lucky to have two really great mentors who were really good at visual expression, because that's how I learned. Some people don't learn by writing things out. Some people really need to draw out the picture, and I'm one of them. So, when I moved on to Stanford, things kind of continued on as they were until I kind of joined in on the science teaching through art program. And it's a series of workshops which teaches graduate students how to be effective communicators. We have a storytelling workshop which works on our science narratives, so you can tell your science to anybody. And we have a workshop on visual design which says, okay, how do I set up my visual aids so they're accessible to anyone? And what I came up with was this, and this is what I showed last year at the STEM poster exhibition here. And actually, what I was aiming for was just to get people excited about science. And when I reflected on it, I actually did a pretty ineffective job of explaining what I actually do. Sure, there's a cool explosion, and maybe that makes you excited, but you have no idea what I do in the lab from this picture. So I want to remedy that, because I feel I made a mistake here last year. So I need a couple people to help me out with a quick demo to explain what I do. Can I get a couple volunteers? Oh, you in the far back? All right, so I need you to hold this hammer. I need you to hold the bus. I'm gonna get the big hammer here. So what I want you guys to do, how about you go on the other side of him? And he's going to use that hammer to tap the bus lightly to send it in motion. So go ahead and do that, and start moving it in response to what he just did over towards me. Yeah. All right, and the bus starts moving. So one hammer gets it moving, and you know what we do in the lab? We take this other hammer and just kind of drop as I hit it. We destroy the bus. So that's what we do in the lab, you guys. Except, clearly we're not using hammers and buses. I think school children everywhere would be kind of afraid of us. But what we do is we study molecules. And what this bus was, it's a molecule. And molecules are what make up chemicals, like bleach and other things we experience every day in our life. Everything is made up of a molecule. And what we do is we take those molecules and we put them in a vacuum chamber and we hit them with a hammer. And the hammer is actually a laser, like what I've shown in this image. It's a very intense laser, and it gets it moving. Then we come in with a second, bigger laser to destroy the molecule, to break it into pieces. And by looking at all the pieces of the bus or the molecule, were able to figure out what it was doing while it was moving. These molecules are so small you couldn't do this with your naked eye, so our only option is to explode them and to measure the pieces, and then work backwards to figure out what's going on. So, now after creating this poster here for the science teaching throughout workshop, I started asking myself, okay, well, how do I add these kind of fun visual aids into my more professional work? And over the summer, I took this poster to a conference. It's much more visual than my posters have been in the past. Usually in the past, my posters are just covered in walls of text. And here I intentionally made the emphasis on the images. And while I certainly didn't have the most exciting research at the conference, I was in the poster session. Like, poster sessions are awesome, and that's where graduate students are. And it's always nice if you get a crowd at a poster session, because it means you did something right. And what I feel I did right is like having the great visuals to get people excited. And I put all the more technical information online. And if you took a picture of the QR code, that's where you got all that information that people really want once they're excited. You don't want the technical things if you're not very passionate about something. Now, what I was studying in this poster is the interaction between light and molecules, like what I've shown. And what's interesting is if you take light, like the light in this room, it's called visible light. It's not very energetic. So if you use that to excite a molecule, the electrons you're talking to are very diffuse. They're spread out over the entire molecule. What I'm showing here is isocyanic acid. It's if I remember this right, an oxygen, a carbon, a nitrogen, and there's a hydrogen atom on the tail. And what I'm showing in the clouds, those are the electrons. So if you use visible light, you're only talking to the really diffuse electrons in the molecule. But as you make it more energetic, as you go to ultraviolet light, this is the light that gives you sunburns. And the reason it gives you sunburns is it packs a punch. And if you use that to talk to your molecule, you're talking to a much more localized cloud of electrons. And if you go to the X-ray, it's entirely centered around the oxygen atom. And you can do cool experiments at the free electron X-ray laser over at SLAC, where you excite molecules with X-rays. And if you have just the right X-ray, you can actually excite this really localized electronic cloud. And what you can do with this is pretty much create a tiny molecular wire. You create this electron cloud here, and electrons are really charged. And they want to move over to this side because it has a positive charge. So electrons are negative, over here it's positive, so they move across. So effectively you create the world's smallest wire, which is pretty cool. May not be novel in the world of physics, but it's a nice thing to think about. Now, through community college and my bachelor's program, I was kind of systematically pushed to think this is how I should communicate my ideas using words instead of compelling visual aids. However, recently, as I've been saying, I've really broken away from this. This is what excites people about what you're doing, and this is how you get people engaged in the first place. There's a time and place for more technical things, but this is how you get people interested in what you're doing in the first place. So if you want people to be interested in you, your work, you should be very visual in representing it. Now, this has helped me in more ways than just professionally. It's also helped me communicate ideas to my family by being more visual. Here I am with my family, my grandmother here, my little brother, my dad, my sister. And as I went through community college and my bachelor's program, I started to get excited about ideas they knew nothing about. I'd go home and talk to them about quantum mechanics during Christmas time, and they'd be like, I don't know what you're talking about. This is all out there, it's abstract, I don't care about it. And what I've learned recently is, well, there's a way around that. I don't have to be isolated from my family just because I'm interested in things they don't necessarily understand. And a good way of helping them to understand and helping them get interested is by drawing good pictures. So what I've done is started actually drawing out what I'm doing in my research instead of sending them the papers I've worked on. I draw it out for them, and I call them up and I say, hey, do you understand this? And if it passes the benchmark of them understanding it, that's when I actually use it in more professional contexts. And it's really helped me bring me back closer to my family, and it's also helped me in my work. Now, it's advice I really give to anyone I serve as a mentor for, if I'm a teacher to them, if they're a friend to me or a family member. I really tell them, you should really draw out hard problems. It helps bring people together, and it really helps you solve them. Any students I tutor, I immediately tell them, you need to draw this out. And what they'll do, they'll draw out what the teacher drew. The X, Y axis and the dotted lines, and it's like, well, this was a problem about throwing the football. Why didn't you draw that first? Because that was probably the idea that first came to your head. And if you draw that picture first, it helps a lot, and your grades really do improve. If you draw the more complicated problem, which is really TMI, and then boil out all the unnecessary information. So I want to talk about another good reason to take time to make good visual aids. But first, just remember the first step to making a good visual is embracing your inner child, having fun with it, draw a cute picture and share it with a friend. Like, they're not going to get mad at you because you drew something for them. So, before I get to my next good reason I think you should work on good visual communication, we're going to do another activity together. And so what the activity is going to be is, in your partners, I need to know who's going to be partner B. So, in the partner pairs, raise your hand if you're partner B. Alright. I hope everyone's decided who's partner B. Alright. Now, you go to the slide. Partner A, you're going to tell a story. So, partner A, what I want you to do is, it could be a story about anything that you're comfortable to share. Just make it personal to you. And so you have the next 30 seconds to tell that story to your partner.
So, for Halloween, I went to my friend in Texas. So that was really fun. I think I found a couple. We were there all the way back. His life was delayed. I just say little, also not good. Baby on the plane, but he didn't cry.
And stop! Alright, story time's over. Now, what we're going to do is partner A has to repeat that story, but they have to say it in the first person, as if it was a story from their own life. So you have 30 seconds to tell your partner the story in the first person. Who shared the story in the first place? I want the partner A's to share with me kind of their reflection on it. What did you hear back from your partner?
Well, I gave him a list of frozen fruit that I took out of the fridge this morning.
So he gave him a list of frozen fruit he took out of the fridge this morning, and he didn't get everything right. All right. Did he make up some that weren't on your original list?
Yeah, I said strawberries. I didn't say strawberries.
All right. Can I have someone else share? No, just share like a reflection.
Okay. He adopted a dog 7 years ago, is becoming a nurse, and works for Allied Health. That's about
Okay.
it.
And did you get all the details right of your story?
General ideas he picked up on, like some of the details right there, but overall I get it.
Mm-hmm. Did he add in any details? Okay. Cool. So it's really interesting to think about the difference between what you say to people and what they actually hear. I have in my head one idea of what you're actually hearing right now when I'm giving this presentation, but it can actually be completely different from the reality. And later on, we'll actually kind of give this a test. Now, really the first thing you got to do whenever creating an effective visual aid or really trying to communicate any concept is you really have to have a lot of empathy for your audience and really put yourself in their shoes. And so real quick, just kind of show what's going on. You may say, like isosceles triangle, and in mind you have a big fat triangle in mind, but what they get in mind is a very pointy triangle. However, if you just draw the picture out, they get a very clear idea of what you were getting at in the first place. Now, to actually kind of come up with effective visuals, really, all you gotta do is try a lot out, okay? You may try out a triangle to represent your idea, and this square guy here is like, yeah, that's great, I got it, I understand it. However, this guy's like, the star person's like, I don't know what's going on, that doesn't make any sense. And the stick figure here is just like, he's off in La La Land, he doesn't get anything at all. So the only good way to know if you're communicating effectively, whether it be like through what you write or with what you're drawing out, is really just to try it out. Just prototype it. Be comfortable with the fact your first idea may not work out. And this really goes for a lot more aspects in life than just trying to be a good communicator. Like if you're applying to jobs, just see the job application as a prototype. I'm prototyping getting a job in industry. If they get back to you and you don't get in, well, it was just a prototype. Who cares if it failed? The first planes didn't fly, but it was like the next step on the path. And whenever you're designing anything, you need to think in these terms. Now, back in the dark ages, the church actually had really great empathy for its audience when coming up with visual aids to explain concepts. For instance, this is the Heartland triptych, and it's an example of illustrated narrative. And over on the far left, you have Adam and Eve being exiled from the Garden of Eden. And in the middle, you have the birth of Christ. And on the far right, you have the end days. So it pretty much tells the whole story in the Bible. And it doesn't do it through words. And it just does it through these pictures you read from left to right. And on top of that, it has a lot more detail in it than you could ever hope to provide using written word. Another example is Illuminating Text. Even when they did write things out back then, they made a lot of effort to really make these nice pictures to really engage their audiences. There are some modern examples of good visual aids. I'm a huge fan of infographics. Sometimes they get a lot of flack because people make these who aren't necessarily experts in the field, and it turns out to be entirely wrong. However, there's really good ones out there, like with National Geographic. Juan Velasco, he makes a lot of infographics for National Geographic, and here's one example. And if you look at this, right here you see Indonesia. And these are different birds that live in Indonesia. And what you can very quickly see is the patterns. Now, the ones most closely related within this family tree here are necessarily ones that look alike. This brown and gold large finch, you might immediately think it's related to this small red one. However, if you look on the family tree, they are, and you also see that they live at a similar elevation. And that's a common pattern throughout all of this. If they're closely related, they all live at the same elevation. So this really quickly communicates some good information. Other examples of infographics, I'm going to kind of shamelessly show some ones that we came up with at Science Teaching through Art this year. This one was made by Kate Follett. She's an astrophysicist over at Stanford, and she images exoplanets. And this is a really hard task, and she came up with a great metaphor for why it's hard. So imagine you're far out in space, away from our solar system, and you want to image Jupiter. But the sun's really bright, so you can't see Jupiter against this background here. And Jupiter is about as dim in comparison to the sun as a firefly is dim in comparison to a lighthouse. So it's really hard to see Jupiter if that's the difference in how bright they are. And not only is the brightness that different, you're trying to look at this firefly going around the lighthouse. And this lighthouse is in California, but you're way over here in Minnesota. So it's a really hard task to separate these two objects. And it gets really even harder if you want to find Earth-like planets. The Earth is as dim in comparison to the sun as bioluminescent algae is dim in comparison to a lighthouse. So they're trying to see bioluminescent algae in the background of a lighthouse at an astronomical scale. So it's a really tough problem. And another example I enjoyed from this year's science teaching through our program is Tori Johnson's poster on cholesterol. She just made it really fun and upbeat, and she had really great visual aids in addition to the poster with her, if anyone visited our exhibition earlier. And there was another one we had that's actually not about her research, it was about protein folding in egg whites. Has anyone ever wondered why if you take egg whites and you beat them really hard, they suddenly turn to cream? It's actually because the kind of egg white gets surrounded by these protein molecules, and those insulate them from the water, and that becomes the frothy mixture. I'll probably get a scathing email from her when she sees this talk saying you explained it all wrong, but that's what I get from the images here. So the two big points I've been trying to hit on here is, why we shy from creating visuals, and I think it's just kind of something systematic that we see written text as more professional, so we use written text even though visual aids really communicate the point better. And I've tried to highlight how good visual aids can really help avoid miscommunication. So what I'm going to do here is kind of a little unusual, is I'm going to go ahead and for the next 5-10 minutes open things up to Q&A, but then we're going to bring it back, and I'm going to actually finish up the talk there. All right? So if anyone has any questions, raise your hand or just yell out.
What do you think about the third form of video, bringing in the actual having talks and stuff like that on the internet? What do you think about bringing that into the educational process as well?
I think videos can be done wonderfully. If you're just kind of videoing a more traditional chalk talk, like the professor at the whiteboard, I don't see that as having any more value than the original talk. It's great to have that information out there, but I don't think it adds any more substance. But there's also really great videos that explain physics out there. And I know Stuart actually watches a few quite regularly. What are a few you can name?
There's metaphysics, there's 60 symbols, there's number file, vibrate, you ever heard that word? Yes. So,
metaphysics, among other examples, if you really effectively leverage the medium to communicate your idea, it's great. But if you're just using it to do the things you normally do, then there's not much value to it. But I think it's really great what some people are doing with video. I think there's the fine line you walk, where you want to get your ideas out there, but you want them to be polished. But the issue is, if you take all the time in this really awesome video that's highly polished, no one's going to build up the courage to be honest with you and say, I don't really like this. You could tweak this or that to make it better. So it's always better if you're setting out to do something like this, just make it rough in the first place and go share the rough draft with people.
Any upcoming projects you're doing?
Any upcoming projects I'm doing. So right now I'm still working on the project I discussed earlier about the electron clouds and using X-rays to actually excite these really energetic, highly localized states and molecules. It's a really interesting problem that requires you to not only model it theoretically on the computer, so you can get some idea of what happens, but also figure out, well, how do I actually do this if I apply for time at the linear accelerator and get time to try this experiment. So.
So your tendency to use visuals, have you met with a lot of resistance in traditional Stanford graduate studies using that in your research or have most people been open to it?
So there has been some resistance even to the science teaching through our program. But what we found is once we for the first time this year did our poster exhibition down on the Stanford campus at home, and everyone who came there, overwhelmingly the response was, I was a little skeptical at first, but these are some very complicated concepts that I haven't been able to understand, that I'm now walking away with an idea of how they actually work. So there's been a lot of appreciation for the people that have kind of experienced the kind of visual aids we've helped to develop.
required to code with visual aids, or is it just more still has to be a professional test?
So what's interesting is if you get a professor at the board who's a professional in his field, he's an expert. He really has expertise at what he does, and I think a lot of times once you reach the level of expertise, you don't necessarily reflect on what you do well. And when you actually let them at the board to draw out what they're thinking, what they're doing, they do it fabulously. They really express themselves really well visually. But when it comes time to do the paper, most people are still locked into this moment. Well, it has to be a paper for a peer-reviewed journal, it has to look like this, and there's no other options. So, in one regard, they do a good job at it, and the other regard, they're kind of a little stuck in their ways. So I think it would be really interesting if there are more ways to actually get work out there, like even novel research that's explained in a much more visual format than just using text to explain our ideas. But that's probably a pipe dream a long ways off. So for now, we all kind of gotta suck it up and deal with the system. And my biggest suggestion is that if you're struggling with a hard problem, you're kind of overwhelmed by the text, is just start trying to draw out your problems to try and understand them, because at least then you're doing something and your mind's working, as opposed to just staring at words on a page, which aren't really engaging any of the mental muscle you need to solve the problem.
What significant achievements have you done by graduating Stanford?
That got me into Stanford. Actually, I think the biggest thing I have to thank for getting into Stanford was my mentors in my undergraduate. The biggest advice I could give to any of you is to reach out to someone you see as being a good fit for you as a mentor and being able to guide you. I got lucky and landed with Grobe and Charles Su, two professors at Illinois State University. We actually didn't have a graduate program in physics, and their only option to have people to help them do their research was to actually enlist undergraduates, and they would actually take people when they were first coming in and then train them up so they could actually be independent researchers in the group. And they made it really clear to me very quickly that I should act like I'm their equal, and if I'm not acting like that, they're not doing effective research together. So really, if you're trying to think about, well, how do I move on in life and stuff like that, you need to find someone you could see would work well for you in a mentor capacity. And don't be afraid to reach out. As I said, it's prototyping. If they say no, they weren't a good fit after all. You were just wrong about who's a good mentor to you. All right, I'm going to take one more question here before I wrap things up.
So let's give Matthew a round of applause. I think he maybe has a couple minutes afterwards.
Yeah,
We
a
have
couple minutes.